Let us say question number 7 is we have two vectors having magnitude 3 and 4 unit, and the question is what should be angle between them if the resultant magnitude is 1 unit. Fine. So again I will try to do it for this. You guys can try it for this and this. Okay. So again we'll use the same result what we are using, a square plus b square plus 2ab cos theta. This is the resultant of two vectors, right? Now a and b is given, magnitude of a is 3, magnitude of b is 4, and what we have to find, we have to find theta in all the cases. Now let us discuss the first case, right? So a resultant magnitude is 1, it is given. So in the first case r is 1. Okay, in the first case r is 1. So this is 1, a is 3, 3 is square, 4 is square, plus 2 into 3 into 4 cos theta. So this will be 9 plus 16 plus 6 for the 24 cos theta. This will be 25 plus 24 cos theta. 1. If I square now both sides, then 1 square is 1 only. So squaring both sides 1. Okay, and this will give me 25 plus 20 cos theta. If I take 25 to this side, so 24 cos theta will be 1 minus 25. So 24 cos theta is minus 24. So cos theta, this is 24 minus 1. And if you recall, theta cos 180 degree is minus 1. So theta is 180 degree. This is the answer of first. Now I will just write down the answer for second and third. You guys can do by your own. Answer of this is 90 degree. If r is 5, then it is this, and for this it is 0 degree. Okay, you guys try by yourself. Now in the next question we are going, next question will be a bit conceptual. So question number 8, the questions is objective type. The component of a vector, first option is always less than its magnitude, second is always greater than its magnitude, third is always equal to its magnitude, and fourth, none. Okay, let us try to understand this. Okay, now component of a vector, let us take one simple example. Let us say I have a vector A, and let us say it is 2i plus j cap. Let us say. Now what will be the magnitude of the vector? Magnitude of the vector will be like we did 2 square 1 square. This will be root 5, and this is 2.23. Now you all can understand this is the x component. I am writing ax, which is 2, and this is, there is 1 here, okay, with j, and ay is this. So this is x component is 2, y component is 1. Now first thing you see, the component of a vector. So we, let us say 2 and 1 are components, always less than its magnitude. Always I will not say, but here you can see this is less than, this is less than its magnitude of this, and this is also less than its magnitude. Okay, but let us in all cases vector is not going to be the same, right? Now I can have a vector, let us say a vector is 2i plus 0j. What will be magnitude? Magnitude will be this square plus this, and you can work it out, 2 square plus 0 square, this will be 2 only, right? Now so a vector always, okay, this word always less than its magnitude, that is not true. It can be equal to its magnitude also, it can be less than also its magnitude. So greater than its magnitude, okay, so you can see, or equal to its magnitude. So out of this, which option will be correct? Okay, I took an example. This word always, try to understand, okay, always. So they are saying the component of vector will be always less than its magnitude. That is not true. Okay, you can see here, this is equal to its magnitude only. This is not correct. Greater than its magnitude, always. This is also not true. Okay, this is the general concept. This is not true. Always greater than its magnitude. Okay, component, how it can be greater than the magnitude itself? Okay, this is also not true. Okay, this is actually if you have a vector a, its x component, we drop a perpendicular, this is ax, and y component is this. They are saying how this can be bigger than this, right? That is not possible. This is not true, this is not true. Equal to, always equal, always is also not true, right? Always equal, they are equal in some cases, always it won't be. So this is also not true, and so our option will be this. Okay, now question number 9. Question 9 says, suppose you have been given, this is first part of the question 9, 2 Newton force acting at an 30 degree. Okay, this is, suppose force F1, F1 magnitude is 2 Newton. The question is, write F1 in terms of its component. Fine. So question is, okay, this is first. In second case, you have a force F2 and magnitude of the F2 is 1 Newton, and it is making 60 degree like this. Now question is, write F1 and F2 in terms of component. Now if you recall the idea, how we find component, we know that if I have to find component at the tail of the vector, I will draw x-axis and y-axis. Then what I do, I draw a perpendicular. This is my fx component, and I drop a perpendicular here. This is my fy, and unit vector along this is I cap, and unit vector along this is j cap. Now what is fx component? So this force F1, right, can be written as fx I component plus fyj component. Again, these components are not a vector quantity. Components is projection, right? Now component is just this length. If I multiply the length with direction, this is a vector. Now what is fx? If you remember, this is 2 Newton, right? Now the magnitude of this vector is 2. So along x, what is the angle? 30 degree. So if you recall the concept, fx should be equal to 2 cos 30 degree, means 2 Newton cos 30 degree. So you guys, cos 30 is I guess root 3 by 2. This is root 3. What is Fy? How much this 2 Newton is making with y? It is making 60 degree, right? Na? So its component will be this length, which is 2 times the angle between this vector and y. So Fy is going to be 2 cos 60 degree. Cos 60 degree is half. So 2 into half, this is 1. So this is, you can say, root 3 and root 1. So vector representation of F1 is Fx is root 3 I plus 1 G. This will be the representation of this force. Now let us talk about the second example. Now, of course, I am going to draw, okay, I have to find component of F2. So what I am going to do, I will draw a tail X and Y axis. Now, of course, this is minus X axis, right? Okay, let us try to do it in two ways. Okay, now, this is 1 Newton. Let me write 1 Newton here. And how much angle it is making with y? This is 60. This must be. Now, you can see F2, if I draw a perpendicular, okay, from here, then this will be my Fx component. Okay, but along minus x. Okay, so I'm just writing a subscript here, minus x. Okay, try to understand. It is along minus x, this. And if I drop a perpendicular here, this will be my Fy. And it is along positive y only. How to write them in terms of components? Now, if this is I cap, this direction is minus I cap. Okay, and this unit vector is I cap, this is minus I cap. Now, what is its F minus x component? What is this component? So this is 1 Newton. This is making this much angle. And if you can see, I can write this F2 as, okay, F, I'm writing just along this direction. So F subscript minus x, this is acting along minus I cap, right? Na? Plus Fy, this is acting along j cap, I. Okay, now this is the key word here, that I am resolving force along x and y. Since this is in along minus x, I can write it like this. Fine. Now, if so, this force has some components along minus x, minus y. What is this minus x? F minus x will be nothing but the force, which is 1 times the angle. So 1 times cos 60 degree. So which is going to be cos 60 degree is half. So I am writing 0.5. And what is Fy? It is making 30 degree. So 1 times cos 30 degree, root 3 by 2. So my force in terms of components will become F2, and this is equal to minus x. This is 0.5. Okay, since we are writing in fraction, let us just write half for 0.5, half along I minus I cap plus root 3 by 2. Now, some of you may ask that what is the component of F2 along x, right? Na? So, okay, aside from the question, you know that it has some component along this. What is the component along this, right? So it turns out that F2 cos 60 degree is acting along minus x. What will be the component along plus x? in this direction, you can write, okay, if you know this is f2, if I draw a vector in opposite direction, this component will become minus f2 cos 60 degree. If they ask, okay, so just you flip it, okay, with a minus sign, and that will be the answer. Now, let us discuss next question. The next question is, the next question is like three forces, let us say F vector and one more F vector and one more F vector. This is given to you, and this is 45 degree, this is 45 degree. Fine. Yeah. Now the question is, find the resultant of this three vectors or force. Now it turns out we know how to add two vectors, but the same method can be used for three vectors. So we have three vectors here. Okay, so let us solve one by one. Now let us just simplify the problem. Let us take, so we have three vectors, we have to find the resultant. Okay, so what I am going to do, first I am just taking F vector and F vector. I am taking this and this. Okay, magnitude are same, they are equal vectors, and angle is 90 degree between them. What will be the resultant of this two? So if you use the result that if I have two vectors having 90 degree angle, what will be the resultant? So resultant of this two, if you recall, it's a square plus b square plus 2ab cos theta. Theta is 90 degree between them, a and b is f. So resultant cos 90 is 0 is going to be just f square plus f square. Fine. And since they are equal vector, their resultant will be acting at 45 degree angle. So resultant of this two will be 2 root f. Fine. Using these two vectors, resultant is going to be root 2f, and what will be, you can see, since they are equal, you find the angle between them. Okay, resultant angle. Then if you guys remember, tan alpha is b sin theta by a plus b cos theta. Theta is 90 degree, so this becomes 0. Okay, this terms becomes 0. This is 1. So resultant sin 90 is 1. So tan alpha is b by a. Both are f only. So alpha will be 45 degree. So if I add this two vector, the resultant is root 2f vector, magnitude of the resultant, and the angle is 45 degree. Right? So these two vectors gives you a resultant at a 45 degree root 2f, and which is nothing but along this, right? Na? So these two vectors have a resultant along this only, which is root 2f. Now the question is simple. Okay, now the question is, okay, let us make it more simple. This, now you have only this question that I have added this two, resultant is this. So my last part of the question is more simple. I have a force F and I have force 2F acting along same direction. Okay, I am not drawing other vectors because there is no point. Now, how you add them? So two vectors have 0 degree angle between them. So how you will add it? Again, so now this is my one vector, this is another vector. If A and this is B, what will be the resultant? So it turns out theta is 0 degree for this two vector, right? We have added this two. So if theta is 0, if you use this result, R comes out to be, okay, if theta is 0, R comes out to be A plus B. just verify this, put theta equal to 0, so it will be a plus b ka whole square. This is a, this is b, so resultant, okay, I am writing r prime, new resultant. So r prime, a is f, this is root 2f, angle between them theta is 0 between them, so r prime will be nothing but f. So this is the resultant. So resultant is acting along this direction at 45 degree and its magnitude is f plus 1 by root 3. Now let us take one more example. This will be, I guess, question 10. Okay. You have been given 4 sets of vectors. So first set is 2, 4, 8. B is 4, 8, 16. C is 1, 2, 1. And D is half, 1, 2. The question is, which of the sets may represent the magnitudes of 3 vectors adding to 0. Okay, in a simple way, which of these sets, okay, one set is the correct answer, which of the set may represent magnitude of 3 vectors adding to 0, means which of the set may give you 0 resultant. Okay, so in the simple way, which of the sets may give you 0 resultant, that is the question. Now so question is, which of the set will represent, may give you 0 resultant. Let us start with this. Okay, this set. You have been given 3 vectors. Now, suppose, okay, just I am taking, we'll take one number and then we'll try to verify. Let us say, these are all forces. Okay, let us say 8 is acting along this. If 2 is acting along this, and 4 is acting along this, so this will give you total 6, right? 2 vectors will add up, angle is 0. So this is 6 and this is 8. They can't add up to 0, right? Now you need at least 8 on this side to balance it to be 0. So that is one way to do. So this is not true. What about this? Let us again take, okay, you can take any number. I'm selecting one number out of it. So B part. Let us take again the bigger number 16. So 16 is acting in this direction. Let us say 4 and 8 are acting in this direction. So you can see 4 plus 8 is 12. So 12 cannot cancel 16. So resultant can't be 0. You need 16 in this direction. This is not true. Now let us take this one. Okay, now C. What? So likewise, if I take this to be 1, right now 1 to 1, we are selecting the bigger numbers. So let us try to take this also, then we'll take 1 also. So let us say 2. So 2 is acting in this direction. If 1 and 1 is acting in this direction, you can see they can cancel each other, right? This is 2, they can cancel with 2, right now. So this might give you 0 resultant. Now if you say, what if I select 1, right? So if you selected 1 in this direction, of course 1 and 2, 3 will not be balanced by this. So these vectors can add, right, in a tremendous way. Okay, we are taking the simplest way. So this 1 to 1 can go like this also. Okay, 1 acting in this direction, 2 is acting in this direction. Connect like this also. But in this case it will not give you 0 resultant. Only in this case it will give you 0 result. Now same way you guys can verify for this also. Okay, for D part, again I am taking, let us say 2, half, and 1 is acting along this direction. You can see that this will not add up to 0. Fine. So out of all the combination of 1 to 1, one combination will be this, which might give you 0. Okay. Now I am giving you one question. You guys try by yourself, and then you let me know in comments if you can't solve it. Okay. So this question is, you have given a regular hexagon. This is vector A, this is vector A, this is vector A, let us say this is a regular hexagon, and this angle is given to be 120 degree. Okay, so how many vectors? A, B, C, D, E, F, 6 vectors are there. 1, 2, 3. Okay, this is a regular hexagon, and these interior angles are given to be 120 degree. So this is first vector, second, third, 4, 5, 6. The question is, what is the resultant of all this vector? Right now, the question is, what is the resultant? Okay, so resultant some of you can answer it very easily. And second part is find x and y component of each vector. Okay, and then third, find net x component, find the total x component, and fourth, find total y component. Okay, now I will just give you a hint here. Resultant will be 0 because resultant is drawn from the tail of the first vector to the head of the last. So this is a closed polygon. Resultant will be 0. So this is solved. Find the x or y component of each vector. So I will just give you one simple example of this vector, let us say. So what you do, if you want to find x and y component, as we discussed, you will draw. So this is my a vector. You draw it separately. At the tail, draw x and y axis. So first vector ka x component is, it is making angle 0. So its x component is a cos 0. It is making angle 90 with y. So ay is a cos 90. Likewise you do for others. Okay. Thank you.